Hey Ramblers, this video covers Chapter 8.1, which introduces us to some of the tools we'll need to deal with our next big topic, which is similarity. Similarity deals with objects that have the same shape, but they're not the same size. And they're the same shape because they have the same angle measures, but the lengths of the sides are different. They're not unrelated, they're all in the same proportion, which means the lengths of the sides have the same ratio. So we're going to explore these terms, ratio and proportion. And we'll talk a little bit about some of the mathematics involved, namely two theorems, the means extremes product theorem and the means extremes ratio theorem, both of which you may have been made familiar with in earlier math classes, but just didn't know the names of them. So I hope this video helps. It'll get us introduced to 8.1, and I'm going to couple it with the next video on section 8.2. Chapter 8.1 covers ratio and proportion. And these two terms are so similar in most people's minds that it's worth kind of comparing them side by side and defining them. Ratios are simply a quotient of two numbers. Okay, that's pretty mathematical. You could think of it as a comparison of two numbers. For instance, 5 to 3. Or that can be written as literally 5 to 3. Or as a fraction, 5 over 3. It's important when you're dealing with ratios to recognize that order matters. So the first number is in the numerator. In this case, that's 5. The second number that someone mentions is 3. So you should know that implicitly in this course and in later math classes that if you're told 5 to 3, that's the order that you should write these things in. The first number is always the numerator, second number is the denominator. So what then is a proportion? Well, it's really closely related to ratio. It's an equation of two ratios. So for example, 2 to 3 to 6 to 9. Or you could write that as literally 2 to 3 to 6 to 9. You can also write it as a fraction, as a kind of an equality between two fractions, but you'll have to wait till I get to the end of the slide to see that. Okay, once again, as with ratios, orders matters. So let's get through this because my example makes more sense when you can see it. So back up to the top, you can see that 2 to 3 equals 6 to 9 is another way of writing a proportion. And once again, the order matters. So the first proportional occupies this spot in the upper left corner. The second proportional occupies the lower left corner. The third proportional is in the upper right, and the fourth proportional is in the lower right. Make sure you know these terms because you may be asked to find the fourth proportional or find the third proportional, and you need to know where to put the variable in order to do that. Okay, there's a little bit more that we can talk about here with proportions, and we know that the first and fourth proportionals are called the extremes. So A and D, as you recall, were the first and fourth proportionals, and we refer to them as the extremes. The second and third proportionals, or in this case B and C, are called the means. So A and D are the extremes, B and C the means. All right, there's an important theorem that comes up here called the means extremes product theorem. You can abbreviate that as M-E, prod theorem. And it says this: in a proportion, or an equality of two ratios, the product of the means, which is B and C, equals the product of the extremes, A and D. In other words, if you know A over B equals C over D, then AD equals BC. This theorem is the justification for all the cross multiplying you've been doing all throughout middle school and junior high. Now, there's another theorem involving proportions that we should talk about, and this is the means extremes ratio theorem. And this one allows us in proofs to switch means and extremes around. Okay, this one's a little daunting with the wording, and you don't need to write it all out or memorize it all, but you should just refer to it as the M-E ratio theorem. So if a product of a pair of non-zero numbers is equal to the product of another pair of non-zero numbers, then either pair can be the means and the other pair can be the extremes. Okay, what does that mean? Well, think of a number, and I'm going to think of 24. And I'm going to come up with two sets of factors of 24, 3 and 8, and 4 and 6. So that satisfies the premise, or the if. I have two pairs of numbers, 3 and 8, and 4 and 6, that both equal the same thing. Well, I can make 3 and 8 my means, and 4 and 6 my extremes, or I can make 4 and 6 my means, and 3 and 8 my extremes. Check the four the four proportions that I wrote down at the bottom, and you can see that sure enough, whether 3 and 8 are the means or the extremes, those four ratios are all valid ratios. That's just the means extremes ratio theorem justifying that. There's another problem that comes up in the exercises, which really is kind of an application of the means extremes ratio theorem. So I'll embed an example of that in this video before we wrap up. But there's two other terms I'd like to cover before finishing up this slideshow portion of the video, and that is the arithmetic and geometric means. Now, it's best just to kind of get the slide filled in and take each term individually. On the left is the arithmetic mean. That's really just another fancy word for the average. So you've been finding the average in your grades in a class. It's the same thing for finding the arithmetic mean. If you want to find the average of two numbers, add them together, divide by 2. Want to find the average of 100 numbers, add up the 100 numbers and divide by 100. So find the arithmetic mean of 3 and 9. No problem. 3 plus 9 over 2 equals 6. So how about the geometric mean? Well, that's also a measure of central tendency, but this time it's using the product of the numbers, where the numbers that you're trying to find the mean of occupy the extremes, and the variable, the unknown, the mean proportional, as it's also called, the geometric mean, will occupy the means of the proportion. You use the means extremes product theorem to cross multiply, simplify, and you see that x equals positive or negative 3 root 3. All right, let's move on to that tutorial before concluding the video. Okay, a problem that comes up in this chapter involves finding the ratio given two pairs of numbers that both multiply out to equal each other. So for instance, if we're told that 7x equals 5y, find the ratio of x to y. Now, I don't know why it is, but students frequently end up getting the reciprocal of what the actual ratio should be. And order matters. So what we'll do is we'll make one of the pairs of factors the means and the other pair of factors the extremes. So I'll make, since I want x to be in the first proportional position, I am going to make 7x the extremes. And I'll write those as x and 7. And since I want y to be on the bottom, that will have to be the means. So y is going to go here, and the ratio of x to y is 5 to 7. Nothing to it. For whatever reason, this often gives students the problem, and we come up with a reciprocal of the correct answer. So please just apply the means extremes ratio theorem, and you really should have no trouble with these.